there is a crater on the Moon that does not behave like a crater. It has been hiding something since before the first life appeared on Earth. No one can explain how it got there. It is a mass, a concentration of material so dense that it is physically pulling the surface of the Moon downward. When NASA's twin GRAIL spacecraft mapped the Moon's gravity in 2012, they caught the edges of it. It took years before anyone understood what the data was showing. And then scientists looked closer. What they found beneath was stranger than the crater itself. So, let's go inside. The thing you have to understand about this crater is that almost no one on Earth has ever actually looked at it. It sits on the far side of the Moon, the side that is permanently turned away from us. It is the oldest, deepest impact basin on the Moon. It is called the South Pole Aitken Basin. And it is so big that the word crater starts to feel like the wrong word. Roughly 2,500 kilometers across, around 8 kilometers deep at its lowest points. If you dropped it onto the continental United States, it would stretch from Texas to Washington, D.C. The mountains along its outer rim reach more than 8 kilometers above the surrounding terrain, forming one of the tallest ranges on the entire Moon. And it has been sitting there, untouched, for roughly 4 billion years. To find the thing underneath the South Pole Aitken Basin, you first have to be able to measure the Moon's gravity with a precision that, until recently, was not physically possible. You cannot do this from Earth. The Moon is too far away, and its near-side blocks most of what matters. You cannot do it from a single spacecraft either, because a single spacecraft flying over the Moon only tells you how much it is being pulled at each moment. What it cannot tell you, not really, is how the pull is changing over tiny distances below the surface. So in 2011, NASA launched 2 spacecraft instead of 1. The mission was called GRAIL, Gravity Recovery and Interior Laboratory. The 2 spacecraft were named Ebb and Flow, and they flew in formation around the Moon, one trailing the other, locked in the same orbit. The entire purpose of the mission was for them to watch each other. As they flew across the surface, denser patches of rock beneath them would tug one of the spacecraft slightly harder than the other. The distance between them would change by amounts almost too small to describe, but the instruments on board could measure it. And out of those tiny changes in distance, GRAIL built the most detailed gravity map ever made of any world besides Earth. In most places, the signal was at least 10 times stronger than the uncertainty. In some regions, the resolution got down to a few kilometers. When researchers finally turned that map toward the South Pole Aitken Basin, they saw something that did not make sense. A crater is, by definition, a place where material was removed. You would expect less mass under it, not more. But sitting beneath the basin, hundreds of kilometers down, was a massive excess of gravity. Something big, something dense, something that had no business being there. In 2019, Peter James, a planetary geophysicist at Baylor University, published the study that made the scale of it clear. He gave the best one-line description anyone has managed so far. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That, he said, is roughly how much unexpected mass they had detected. The minimum mass of the anomaly, as reported in his paper, is more than 2 quintillion kilograms, a 2 followed by 18 zeros. And that is the lowest number the data allows. It is the number you get if you spread the anomaly across the entire thickness of the Moon's mantle. Try to squeeze it into a thinner layer near the surface, and the required mass goes up. Try to confine it to the top 100 kilometers, and the models simply stop working. They cannot reproduce the gravity and topography data at the same time, which means the anomaly is not shallow. It has to extend at least 300 kilometers down, probably much deeper. And it is heavy enough to physically deform the Moon. The floor of the South Pole Aitken Basin is being pulled downward by more than half a mile by whatever is underneath it. You can see the depression from orbit. It sits exactly over the center of the gravity anomaly. The surface of the Moon is being warped by something we cannot see. There is one more strange detail. The anomaly is not centered in the crater. It is offset. The center of the mass excess sits about 400 kilometers to the southeast of the geometric center of the basin. For a structure this big, that offset is not a rounding error. It is a fingerprint. It is telling you something about how the mass got there, and researchers checked the surface for any clue that might explain it. Mineralogy data, maps of ancient lava flows, nothing correlated. From above, this part of the far side of the Moon looks like what it is: a large, old, quiet crater. From the inside, it is hiding something enormous. So, what is it? The 2019 study offers two explanations. Both of them, in their own way, are staggering. The first is that it is a piece of the asteroid that made the crater in the first place. When the South Pole Aitken Basin formed, the object that struck the Moon was not a rock. It was a small world, large enough, possibly, to have been differentiated, meaning it had a core of its own, made mostly of iron and nickel. And under the right impact conditions, hydrocode simulations show that the metallic core of a differentiated impactor does not necessarily punch straight through or bounce away. It can get dispersed, shattered into smaller fragments, suspended inside the upper mantle of the body it hit. James and his colleagues did the math. A sufficiently dispersed iron and nickel core could, in principle, remain floating in the Moon's mantle for billions of years without sinking down to the Moon's own core. And when they checked what size of impactor core would match the anomaly they were measuring, the answer came out to about 95 kilometers across. A metallic lump roughly the size of a small asteroid, broken into pieces, still hanging in the Moon's mantle, exactly where it landed 4 billion years ago. As James put it, the metal from the asteroid that formed this crater is still embedded in the Moon's mantle. The second explanation is more subtle, and in some ways even stranger. It says the mass is not foreign at all. It is a leftover from the Moon's own birth. When the Moon was young, most of it was molten, a global ocean of magma, slowly cooling from the outside in. As that magma ocean solidified, different minerals crystallized out at different times. The last minerals to form, late in the cooling process, were heavy, rich in titanium oxides, and denser than the rock around them. At some point, these dense layers should have undergone a process called mantle overturn. Heavy material sinks, light material rises, everything rearranges itself. But overturn does not have to be efficient. It can leave pockets behind, stranded. And a pocket of those late-stage oxides, caught in place under the South Pole Aitken Basin, would produce a mass anomaly of roughly the right magnitude to explain what GRAIL found. So those are the two candidates: a metal slug from a dead impactor, or a frozen relic of the Moon's own formation stuck in a place it was never supposed to end up. And the honest answer, right now, is that no one knows which one it is. When James was asked how the question could be settled, his response was simple. The best way to rule out one scenario or the other, he said, would be to perform newer and better simulations. Now here is the part that is quietly more interesting than the mystery itself. The simple fact that the anomaly is still there, still intact, still concentrated after 4 billion years, tells you something specific about the inside of the Moon. On a warm, soft planet, a dense chunk of metal or oxide would not stay where it landed. It would sink. Gravity would pull it down through the surrounding rock, slowly but steadily, over geologic time. For a mass this large to still be sitting roughly where it was emplaced, the mantle of the Moon has to be stiff enough to physically hold it in place against its own weight. That places a lower limit on the viscosity of the Moon's interior. And viscosity, in planetary terms, is tightly connected to temperature. A hot mantle flows, a cold mantle resists. When the researchers worked through the math, the result came out to something specific. The lower mantle of the Moon, for roughly the second half of its history, has had to be cooler than about 1500 degrees Celsius. That sounds hot, but for a deep planetary interior, it is actually on the cool side. It means the Moon has already lost a significant fraction of its original thermal energy. It has been quietly cooling and quietly hardening for a very long time, and the anomaly has been sitting there through all of it. Through the late, heavy bombardment, through every major impact the near side ever recorded, through the slow formation of the Maria, through the entire span of Earth's biosphere, from the first cell to every creature alive right now, it has not moved, it has not dispersed, it has not sunk, a silent weight in the dark, pressing on the ceiling of the Moon from below. While GRAIL was measuring the deep interior, another set of discoveries was being made much closer to the surface. And they turned out to be connected to the same question. What is the Moon actually hiding from us? In 2009, the Japanese lunar orbiter Selene, nicknamed Kaguya, was photographing a volcanic region on the near side of the Moon called the Marius Hills. And in one of those images, researchers spotted a hole, nearly circular, steep-walled, darkness at the bottom. It was one of the first lunar pits ever properly identified. It was not alone. Follow-up observations by NASA's Lunar Reconnaissance Orbiter, using its narrow-angle camera, have since catalogued more than 200 pits across the lunar surface. They range from about 5 meters across to more than 900 meters across. Several of them show clear overhangs, meaning the pit is not just a depression, it is an opening into something deeper. The thing they lead into is what you would expect from a world that used to be volcanically active: lava tubes. But on the Moon, lava tubes do not behave like they do on Earth. With only about 1/6 of Earth's gravity and no atmosphere, lunar lava tubes can grow to sizes that would collapse instantly anywhere else. Work based on GRAIL data suggests that some of them are more than a kilometer across. Stable, intact, still there. In 2017, a combined analysis of Selene's radar sounder data and GRAIL's gravity map confirmed the existence of a large, intact lava tube near the Marius Hills skylight. The radar picked up a distinctive echo pattern over the hole. A drop in echo strength followed by a strong second peak, exactly the signature you would expect from a radar beam bouncing off the ceiling of an empty tunnel. The gravity data showed a matching mass deficit in the same place, as if the ground there were hollow. The tunnel, researchers estimated, is large enough to fit a major city inside. The visuals they produced to explain the scale used the outline of Philadelphia. Then in 2023 and 2024, radar imaging of a pit in Mare Tranquillitatis confirmed the existence of a cave conduit beneath it, at least tens of meters long. That was the moment anyone could say, with physical evidence in hand, that the Moon has caves. There is one more thing to say about these caves before we come back to the anomaly, because they turn out not to be just geological curiosities. They are one of the reasons the Moon is suddenly, seriously, being talked about again as a place humans might actually live. The surface of the Moon is violently hostile. During the long lunar day, which lasts about 15 Earth days, surface temperatures climb to around 127 degrees Celsius, hot enough to boil water. During the equally long lunar night, they fall to around -173 degrees Celsius. There is no atmosphere to buffer any of this, no magnetic field to deflect cosmic rays, no protection from micrometeorites. An astronaut on the surface is exposed to all of it all the time, but inside a lava tube, everything changes. In 2022, a team led by Tyler Horvath at UCLA, using the Diviner Lunar Radiometer experiment on the Lunar Reconnaissance Orbiter, published a study on the thermal environment inside the Mare Tranquillitatis pit. They found that the permanently shadowed sections of the pit stay at a roughly constant temperature of around 17 degrees Celsius, year-round. day and night. Roughly the temperature of a comfortable room on Earth. The overhang blocks direct sunlight during the lunar day and then stops that same heat from radiating away at night. The cave is regulating itself. David Page, one of the co-authors of the study, put it plainly. "Humans evolved living in caves," he said. "And to caves we might return when we live on the moon. It is a strange idea that the first permanent settlements off the Earth might not be built on the surface of the moon at all. They might be built inside it. Inside tunnels carved out by lava billions of years ago, when the moon was still young and still warm, and still capable of the kind of activity that could leave a cavern the size of a city behind. So let us put the picture together, the way we actually understand it now. The moon is solid, it is layered, it has a crust, a mantle, and a small dense core. Its lower mantle has been slowly cooling for billions of years and is now cold enough and stiff enough to hold a mass anomaly in place for the entire history of Earth's biosphere. Its outer shell, down to roughly 200 kilometers, is so fractured by ancient impacts that it behaves like a natural echo chamber, scattering seismic energy for hours after a single strike. Closer to the surface, it is riddled in places with enormous empty tunnels, some of them large enough to hold cities, left behind by rivers of lava that have not flowed in billions of years. And beneath the largest crater in the solar system, several hundred kilometers down, something very heavy is pressing upward on all of this from below. More than 2 quintillion kilograms of it, possibly the dispersed iron core of a dead impactor. Possibly a pocket of the moon's own oldest material, stranded when the rest of the interior sorted itself out. Here is the part that is worth sitting with for a moment. Almost everything in the paragraph you just read came from data collected in the last 20 years. None of it was known when the Apollo astronauts came home. None of it was known when the Soviet probes stopped flying. The lunar pits were discovered by accident, in images no one was originally searching for holes in. The mass anomaly was found because 2 spacecraft watched each other, orbit after orbit, for long enough to notice that the ground beneath them was tugging one of them harder than it should have. The caves were confirmed only when radar data from one country lined up with gravity data from another, on the same hole, from 2 different instruments pointed at 2 different things. Terry Herford, a NASA geophysicist working on the next generation of lunar instruments, has said that our understanding of the moon's interior remains rudimentary and is limited. He was not being modest. For a world this close, this visible, this familiar, the moon is still full of things we have not yet measured, and more is coming. Herford is developing a new instrument called the Subsurface Lunar Investigation and Monitoring Experiment, designed to map the moon's core in a way the Apollo seismometers could not. It is being built for the Artemis program, NASA's effort to return humans to the moon for the first time in more than 50 years. In October 2024, NASA published its updated list of 9 candidate landing regions for the Artemis 3 mission. All of them cluster around the lunar South Pole. None of them are where Apollo went. The South Pole contains permanently shadowed terrain that may have preserved water ice for billions of years, some of the oldest surface material on the moon, and the edge of the very basin whose interior hides the mass anomaly. Other missions are already in flight. China's Chang'e program has become one of the most active lunar exploration efforts in history. In January 2019, Chang'e 4 became the first spacecraft ever to land on the far side of the moon, touching down inside the von Karman crater, which sits within the South Pole Aitken Basin itself. In May 2024, Chang'e 6 launched, and on the 1st of June of that year, it became the first mission to return samples from the far side, collecting material from the Apollo basin inside the same larger system. None of these missions have answered the central question. None of them were designed to, but each of them has added a piece. Each of them has narrowed the possibilities, and each of them has gotten us a little closer to understanding what is actually under the far side of the moon and what it has been hiding, for all of human history, right above our heads. The moon has been in the sky for as long as anything has looked up. Before there were humans, before there were oceans on Earth, before the first cell divided in the first warm, shallow water, it was already there, waiting quietly in orbit, while the planet beneath it changed beyond recognition. And the strange part is that the more closely we have looked, the less familiar it has become. Not more, less. Every new mission has found something the last one missed. The pits, the city-sized tunnels, the cool, quiet rooms holding their own temperature through the brutal swings of the lunar day. And beneath the oldest scar on its surface, a mass of something we still cannot name, large enough to bend the floor of a basin the size of a country. It is not a hollow moon. It is not a spaceship. It is not any of the things a misread phrase from 1970 once convinced people to believe. What it is, in some ways, is stranger than any of those ideas. A world that is almost entirely solid, almost entirely silent, and still, somehow, full of things we are only just beginning to read. Whatever is beneath the South Pole Aitken Basin has been there longer than life on Earth. It was there when the first animals crawled out of the sea. It was there when the dinosaurs walked, and when they died. It was there when the first humans looked up at the night sky and tried to explain the bright circle hanging above them. And it is still there right now, buried under billions of tons of ancient rock, waiting to be understood. For now, all we can do is keep looking, keep flying new missions, keep listening to the echoes. Every answer, so far, has brought another question with it, and that is how science moves forward, not by closing the book, but by turning the page. The moon is not what you think. It never has been. And the more we study it, the stranger it becomes. What we know so far is based on the best available data from the Apollo missions: Lunar Prospector, the Lunar Reconnaissance Orbiter, GRAIL, Selene, and Chang'e. Here is what the data suggests. The moon is solid, ancient, and hiding at least one enormous mass anomaly beneath its largest crater. Some researchers believe the anomaly is the buried core of an impactor. Others argue it is a relic of the moon's own formation. What if both are partly right? For now, the data is still coming in,